Okay, welcome to section 6.6, analyzing the graphs of quadratics. We have graphed quadratics before, or parabolas. This is a different technique. We're going to examine them in vertex form. The vertex form of a parabola looks like this. Equals a parentheses x minus h squared plus k. In this form, h comma k, notice the sign here, okay? HK is the vertex of the parabola, so HK would be here. This would be the coordinates of HK, okay? Is the vertex. A determines which way this is shaped. If A is greater than 0, it's going to be opening upward, so this is what that looks like. A is greater than 0. If A is less than 0, then it will be turned downward. Alright, let's give an example. If I had y equals 2x minus 4 squared plus 3, then the vertex would be at 4, 3, and it would open up. It would open up because 2, here a is 2, which is greater than 0. Here's another example. If y equals, let's see, 4x plus 3 squared minus 7, then the vertex would be negative 3. You want to take the opposite of that, but you want to keep the same sign as this one. So it's negative 3, negative 7, and it will open down because a is negative 4, and that's less than 0. Alright, basic graphing of this. If I were to graph the second one here, negative 3, negative 7, negative 3, negative 7, way down here somewhere. And it's opening down, so it'll kind of look like this. Oops, can't see that. Alright, there you go. So, assuming this is the vertex of negative 3, negative 7, we know it's opening down. That's it. Depending on how picky your teacher is, you may want to plot a point to the left and to the right of the vertex. To do that, well, if you know the vertex has an x equals negative 3, then to the left of that will be x equals negative 4, and to the right of that will be x equals negative 2. Just plug in negative 4 and negative 2 into the original equation, and that should give you your points. Alright, another way to look at it, if you go 1 unit to the left, you should go that many units from the vertex. So you would go 1 unit to the left and go down 4. I think. That's what I've been telling my students. I hope that's true. Okay. Anyways, here we go. I'm going to do a problem from the worksheet now. Here's number 1. Now, the examples I just showed you have the vertex form. The problems on the worksheet are not in vertex form. So what we're going to do is complete the square to turn these into vertex form. Now, the different part about this, okay, and when we did complete the square before, it was one way, and we completed the square in a different way here. What we're stuck with is on the one side of an equation. So that's going to change a little bit. Here, I'm rewriting this. I'm making space to complete the square here, and I'm putting my plus 5 over here. Alright, now, to complete the square, remember, you take the linear term, the coefficient of the linear term, divide by 2, or take half of it, and square it. So it's going to be plus 1 squared. Now, we're on one side of the equation, so I have to compensate for this addition of 1. So I'm going to subtract 1 out here. Alright? So here, I have purposely made this perfect square. So this becomes x, bring down that sign, plus, bring down that 1. And simplify the right-hand side here. 5 minus 1 is 4. Okay, so now I have it in vertex form. You might think I'm missing an a, but remember, if there's no number, the number is 1. So you can think of a as 1 here. So my vertex is negative 1, 4. And it's going to open up because my a is 1. So when I graph this, it's at negative 1, 4. It's going to open upward, and it's going to look like this. it'll probably cross at 5. I mean, not probably, it will cross at 5. Okay. Okay, that's number 1. It's open upward, vertex is at negative 1, 4. Number 2. Alright, this is number 2. Okay. Now, whenever we complete the square, we generally do not want a leading coefficient. So what I'm going to have to do is take out a 4. Now, when we take out something, when we factor out a number, it doesn't have to be common. It doesn't have to be common. But when we take it out, we only take it out of the first 2 terms. Because this 34 out here is going to be part of my y coordinate of the vertex. Now, okay, so now we're going to complete the square in here. We take half the middle term and square it and add it. So it's plus 3 squared. To compensate for this 3 squared, you might think I just have to subtract 3 squared out here, but that's not true. This 3 squared gets multiplied by the 4. So essentially, I'm adding here 4 times 9. So I have to make up for that by subtracting 4 times 9, 36. So this 36 comes from having to compensate for 4 times 9. 4 times 9 is 36, so I have to subtract 36. Alright. So my perfect square is x minus 3 squared. And that's a minus 2. So my vertex is 3, negative 2. Right? Opposite of that, same sign as that. And it opens up. Okay. So 3, negative 2. 2, 3, down 2. Up 1, up 4. And there we go. Okay, that's it. That's number 2. Number 3. Okay, number 3. Same thing. I have a leading coefficient, so I have to factor that out. But I don't factor it out of 5. So factor out negative 2 from negative 4, I get positive 2. Put the minus 5 out here. Half of 2 is 1. Square it. Well, 1 squared is 1. Okay. Now this time I'm compensating for negative 2 times 1. So I've actually subtracted 2. So to compensate for the minus 2, I add 2 out here. So my perfect square is x plus 1 squared. And I got negative 5 plus 2, which is negative 3. So my vertex is at negative 1, 3. Remember to take the opposite of that. I'm sorry, negative 1, negative 3. I took the opposite of both. Alright, so take the opposite of that, keep that sign. This is going to open down. This vertex, I'm sorry, this parabola is opening down because a equals negative 2. Okay, so when I graph this, negative 1, negative 3, it's going down. Okay, that's it.